Cool.
Hopefully we won't have any technical problems, which I've been having all day with students. Losing
Oh,
video
really?
and stuff, yeah. I think it might have
Interesting.
something to do with the massive Yahoo hack that they just discovered today.
Oh, did they really?
1 billion Yahoo accounts got hacked, and
Wow.
it's not so much if you lose your Yahoo, but they stole passwords, social security numbers, dates of birth. So
Oh
they're
my
afraid that
God.
they'll use that information on other things like, banks and try to log in with those same passwords and stuff. So their suggestion
Right.
is that everybody change their passwords to everything today. Well, what
Wow.
kind of massive traffic jam is that going to cause on the internet?
Oh, it's just gonna be absolutely
Yeah,
like absolute
and
chaos,
I think that's maybe what was happening today. I don't know.
Yeah. Jeez.
So, how do we handle these three different looking fractions?
So first we need to find least common denominator, right?
Okay, yep.
And that would be
And
2x squared.
when you decide that that's what you need to
Uh-huh.
do it as detailed as you can so that you can follow your path. And
Okay.
you think it's 2x squared?
Yeah.
Yeah, you don't need to multiply the x times the x squared. In other words, it's not necessarily the product of all three.
No.
It's just the smallest thing that each of these denominators divide into evenly, and that's
Cool.
2x squared.
Cool. When you set up the three fractions, would that be a negative instead of a positive for
Yeah,
the second one?
yes.
Okay. Okay. No, you're fine.
Sorry.
Just just making
If
sure. I was
that's the
like,
worst mistake I make, I'm in good shape. But
that's all right.
no, I mean just because my brain is almost fried here.
Oh, I bet.
Now it's
Yeah.
pretty
No.
easy to figure out what goes there. What goes there?
Um,
Can you see where I'm
2x.
pointing? The numerator of the far left term.
Yeah, so 2x squared.
No,
And then
if I made it 2x squared, then that's equal to 1, which has changed it.
yeah.
I got to make sure that whatever I put up there reduces to 1/2. So what
Oh,
could I put here so that it's the same as 1/2?
um.
Here's,
We.
here's the way to actually do it, Dylan. The
Okay.
technical way is to take your common denominator,
Uh-huh.
divide it by the denominator of the top. What do you get?
Oh, so you get 1x squared.
Right. And now if I put that there, it's really easy to see that that is the same as that.
Okay.
Right? I mean, you can
Yeah.
see it. In other words, you can immediately check your work
Mm-hmm.
and make sure you've done it right. And you always want to be doing that. At every
Okay.
step along the way with math, always make sure that you haven't changed it. Because that's the
Okay.
goal when you're doing this, is to make sure that this term here is exactly the same as this term here. So
Okay.
now here, I'm going to take my common denominator and divide it by x. What do you get?
So you get 2x squared.
Nope,
Well, no, you just get x squared.
nope.
Well, 2 divided by x
Hold
is,
on. The 2 stays in the numerator. What's
yeah.
that?
Oh, x,
Just
just
x.
x.
Yeah.
Yeah.
Subtract exponents. Well, 2
Okay.
minus 1 is 1.
Okay.
All right, so that's what goes in this numerator.
Okay.
Hold on. That's not right either.
Yeah.
What does this
What did,
have to be? It has to be a 4, doesn't it?
yeah, yeah, 4x, or just 4.
So I made a mistake when I was describing to you how to come up with it. What you
Okay.
do is you divide your common denominator by your denominator. You take
Uh-huh.
that and you multiply it by the numerator, which is 2.
Okay.
That's how you come up with 4x as the correct answer. In other words, I take this 2x, I multiply it by 2 because
Mm,
2 is in the numerator.
Okay.
That's how I get the 4x. And now if you look at this, you can see that's the same as that.
Yeah.
4 over 2 is 2, and
Mm-hmm.
x over x squared is x in the denominator.
Okay.
Okay? What about over
Uh-huh.
here? To
And
put
that
in the
one,
numerator to make it the same as this.
6x.
How about just 6?
Would 6 work? Yeah, yeah, that makes sense.
And let's do it by our methodology that I showed you, because
Uh,
you should always use this method over here. Take our
okay.
common denominator, divide it by
Uh-huh.
this denominator, x squared. What do you get? 2. And then
Yep,
multiply it by this numerator.
which is 6.
That's what goes in the
Minus.
numerator.
It'd be minus 6. Yeah, okay.
Okay? So
Cool.
now this whole thing becomes x squared plus 4x minus 6 all over 2x squared. And that's your final answer.
Cool.
I really cannot do anything. I can't factor the top. I can't
No.
divide every term by 2. I can't do anything. That's the final answer.
Okay.
All right?
Cool.
Yeah, we're not even going to have time to get through all of these.
Yeah.
So this probably makes more sense for us to do it.
Oh,
All
for
right.
sure.
So this one, this one's going to have a little catch to it also that you have to be careful about.
Okay.
What's my common denominator?
Um, so the least common denominator would be, just would it, oh,
Now in this case, the best you can do is just to multiply the two.
so x squared plus
No,
5.
no, don't multiply them out.
Oh, okay.
Just show it like that. It's always better to leave it in factored form unless you have to multiply it out. We may have to
Okay.
at some point, but don't do it until. And I'll show you why.
Okay.
What goes here? Certainly
Hold.
3. Can I figure out the other term easily
Uh,
so that it's the same as this fraction here?
well,
What is it?
no.
Yeah, x plus 1.
So,
Isn't that the same? In other words, that x plus 1 cancels with this x plus 1, leaving you with 3
right.
over x plus 5, which is what we started with.
Okay.
Okay? So
Yeah.
you could do it the hard way, the way we did it on the last problem, but after you kind of get used to doing this, you'll see that this is actually the easier way to do it. And that's the reason I didn't multiply the denominators together. Is because
Okay.
if I multiplied them together and got a quadratic, I wouldn't be able to tell whether this fraction was the same as that one.
Yeah.
But as long as I left them just as two multipliers,
Uh-huh.
now I can tell that if I put an x plus 1 there, that would cancel with that, and I'd be left with 3 over x plus 5.
Okay.
Okay, well, let's do the same thing over here. Let's put a 4
Mm,
there. And what must I have to put there?
x plus 1.
Not x plus 1. If I put x
Oh,
plus 1, I'll have an x plus 5 left over. Remember, I want it to equal this. It's got to be equal to that by the time I'm done. So what has to go here?
um, um,
If I did
x,
what you said, if I did x plus 1, well, then that would cancel with that, and I wouldn't have the same thing.
no.
Okay, so what does it have to be? Not x plus 1, but what?
X plus 5.
X plus 5, exactly.
Okay.
Now I cancel that with that, and I'm left with 4 over x plus 1, which is what I started with.
Okay.
That absolutely is the secret to all of these, is always be checking. I can't say it
Okay.
often enough. Okay?
Cool.
Now,
Okay.
what is this equal to? Well, I'm
Uh,
still going to leave the bottom in factored form. No reason to multiply it together yet.
yeah.
But I do have to distribute the top because I can combine some terms here. I know I'm at a minimum, I'm going to have 3x minus 4x.
Yeah.
Okay, so let's go ahead and distribute that. So that becomes 3x plus 3.
Mm-hmm.
Now be very careful here.
Okay.
Make sure you hold, because subtraction is taking place, make sure you use parentheses,
Yeah.
right?
Right.
Now, when you remove the parentheses, you can distribute this negative sign to both terms.
Uh-huh.
What's the new numerator?
Um, minus x minus 17.
Good.
Okay. Cool.
Yeah, because that turns into a minus 20 when I remove
Yeah.
the parentheses. And then I have
Yeah.
3 minus 20, that's minus 17. And then the
Cool.
bottom, I'm just going to leave it in factored form because there's no
Yeah.
advantage to multiplying it out. And factored is actually a better answer. Most
Uh-huh.
mathematicians would tell you they'd much rather have it in factored form because
Uh-huh.
if it's multiplied out, sometimes the very first next step would be to factor it. So
Yeah.
you don't necessarily want to do something that'll cause you to go backwards.
Okay.
And that's your answer.
Cool.
All right.
If we could do number 11, just so I can understand how to do it.
Okay.
Um, yeah, because that looks kind of confusing.
Well, there's a couple ways to do this.
Okay.
And I'm not sure if it was you or somebody else that said their teacher actually suggested a slightly more efficient way than I was used to doing it.
Oh, okay.
Still not sure I like it better. In fact, the more I think about it, I don't think I do.
Okay.
I think I like the way I used to do it.
Okay.
The way I used to do it, I would combine both terms in the numerator and I would combine both terms in the denominator. And I still
Okay.
think that's by far the best way to do it. Instead of, which is what I heard from one of my students, that you find a least common denominator for all of these subfractions.
Oh, jeez.
In other words, trying to find a least common denominator between 3x, x plus 2, and x.
Uh-huh.
Problem with doing that is it's hard to make sure you're not making mistakes. Whereas if
Right.
you do it the way I'm going to do it,
Uh-huh.
I'm just going to do the numerator first, and then I'm going to do the denominator.
Okay.
So what's the least common denominator for the numerator?
Um, just 3x plus 2.
3x times x plus 2.
Or 3x, would it be times? Yeah.
Yeah, always.
Yeah.
If I'm
Yeah.
adding 1/3 plus 1/4, my least
Uh-huh.
common denominator is 12. I'm multiplying
Okay.
3 times 4 to find that least common denominator. That's not really guaranteed to be a least common denominator, but it's guaranteed to be a common denominator always.
Okay.
Now, sometimes it's least, but that's not really a problem if you come up with a common denominator that's not the least one, but it's still a common denominator.
Right.
When you have expressions like this is the least common denominator also.
Okay.
In other words, you at a minimum, remember, you have to be able to divide your least common denominator by both of these expressions and come up with a non-fraction.
Okay.
Well, if I divide that by 3x, I get x plus 2. That's good. If I divide
Hmm.
this by x plus 2, I get 3x. That's good.
Uh-huh.
Okay? So
Okay.
now, what has to go there?
Um, so to get that, just Uh,
Rather than thinking
1.
about the method to get it, which I showed you, and I was reluctant to show it to you, because I
Yeah,
don't
would it
think
be
that's
1?
the
1
easiest way
and,
to do it. To me, the
yeah, would,
easiest way to do it is to visualize it.
yeah,
What could I put there such that this whole fraction is the same as this, which is what my goal is?
yeah. 1 times x plus 2,
Just x plus 2.
or just x plus
Just
2, yeah.
x plus 2. Now that cancels with this, and I'm left with 1.
Mm-hmm.
Okay, you don't necessarily have to write the 1,
Uh-huh.
and if I have anything else there, I don't have to write the 1. I wouldn't
Okay.
want to write the 1.
Uh-huh.
Okay, how about over here? What
Um,
over here will make it the same as that fraction?
4 times 3x.
You got it. That's 12x.
Cool.
But I actually preferred the way you said it.
Okay.
If I write it like this, 4 times 3x, well, now I can
Uh,
see the 3x's cancel, and I'm left with 4 over x plus 2.
yeah.
I'm absolutely certain that I've done it correctly if
Cool.
I write it the way you said it.
Sweet.
All right,
Alright.
now let's look at the bottom.
Yeah. So the denominators would be x and then times x plus 2.
Yep.
And then for the first one, um, it would just be x plus 2.
Well, no. Remember, we have to end up with it being this. If I wrote x plus 2, that'd be the same as 1 over x.
Well, like you want the x plus 2's to cancel out though, right?
No,
Oh, no, no, wait. No,
I
never mind,
want
never
the x's to
mind. Yeah, you put an x. Yeah, you put an x in the
hold
numerator.
on. Is that the same?
Well, yeah,
No,
no,
it isn't. That x would
no,
cancel with that x, and I'd be left with 1 over x plus 2, which is not what I have over here.
no. Um,
How about x squared?
oh,
Now,
so the x's,
is
yeah,
that the
yeah,
same?
yeah,
It definitely is,
it definitely is, yeah.
because this x would cancel out with one of those x's, and I'd be left with x over x plus 2.
Cool.
Okay? Now,
All
the
right.
technical way that I got it was,
Uh-huh.
I'll review that with you since you have a little bit of trouble with this. I take my common denominator, I
Uh-huh.
divide it by this denominator, x plus 2.
Uh-huh.
That gives me x, and then I multiply that by the numerator. That's how I get x squared.
Okay. Cool.
All right, how about the 1 over x? What do I need to put up here?
Um, yeah, so you would put, let's see here. So you want a 1 over x, so you put x plus 2 in the numerator.
That's the way to do it. Notice you
Okay.
were able to do it without going through that long division process.
Yeah.
And that's the best way to do it, is to just kind of see it and figure out that this got to be it, because this will cancel with that, and I'll be left with 1 over x, which is the same as that.
Yeah.
Okay, so now I'm going to write it this way. X plus 2. I'm going to put parentheses around everything.
Okay.
Well, not maybe everything, but there's the common
Uh,
denominator in the numerator.
uh-huh.
And I'm going to draw the middle fraction bar extra long so I don't get confused.
Okay.
And the bottom is x squared plus x plus 2 over x times x plus 2. You
So
with me?
x. Yep. Mm-hmm.
Now, because the denominator is a single rational quotient, I can flip and multiply.
Okay.
You can only flip and multiply when you get a single rational quotient. In other words, if my bottom is this, I can't flip and multiply.
No.
I got to turn that into 1/12, which is what it is. Okay?
Uh,
So I've got to turn it into what is called a single rational quotient. Now I can flip and multiply. So I'm going to do that up here without rewriting it.
Yeah.
Make sure you see what I'm doing and
Uh-huh.
understand. And then I'm erasing. Wow, I'm trying to erase. My, my technology is failing me here.
Okay, no worries.
All right, now I'm set to
How,
continue, okay?
okay.
Now
How did you
notice
get,
what, go ahead.
oh yeah. How did you get x, x plus 2 and then,
I just flip the bottom and multiply.
oh, that's how you do it. Okay.
Yeah, in other words, let's see if I can recover the bottom. What's going on here?
No.
You see that the bottom is this flipped?
Uh-huh. Yeah.
Exactly.
I do see that. Yeah.
That was the whole reason I combined the two fractions in the bottom, was so that I
Okay.
could get it to a single rational quotient that I could flip and multiply.
Okay.
Now notice what happens. I've got all kinds of things. I can cancel that x plus 2 with that x plus 2. That's why I didn't multiply these things together in the first place, because I wanted to be able to cancel where it was possible to cancel.
Yeah.
Okay? Now, this one is x minus 12x, so that's minus 11x plus 2. You with me? Is that?
Not really. Oh, okay.
I've
Gotcha.
combined the x and the minus 12x,
Okay.
and it's being multiplied. We still have an x there, and
Yeah.
this bottom is now 3x, and this bottom can't factor that, so I'll leave it like that.
Okay.
But I can now cancel that x with that x.
Okay.
So now I have in the numerator minus 11x plus 2 is the only thing I have left in the numerator. And the denominator is 3 times x squared plus x plus 2. And whether you choose to multiply that together or not, I don't think matters a whole lot. There's your answer.
Okay. Cool. Wow, that's a lot of work.
Definitely a lot, but that's a big problem too.
It is.
If you
Yeah.
look at it, you got two different fractions in the numerator, two different fractions in the denominator.
Uh-huh.
That's the way we're going to handle these kind of problems. No matter how complicated they are, you can always do them. Notice
Okay.
the next one is actually easier.
Uh-huh.
Why? Because I already have a single rational quotient in the numerator, and it's all I have to do is combine the denominators.
Okay.
In the denominator, what is the least common denominator?
Um, in the numerator, the least common denominator would be,
No, not in the denominator. Here,
well, on
let
top.
me let me write it so I can expand it. This will be the last one we do.
Oh, okay.
Where's your toothbrush?
It's in there. It's in the drawer. It is.
Okay, Ethan, she's coming in. If she needs to get her toothpaste, go to bed.
All right, so we don't have to do much with the numerator yet.
Uh-huh.
In other words, I could simplify that a little bit. I could divide top and bottom by 2,
Tell
but
Mr.
let's
Kelly.
not do it until we need to.
No. No.
You just didn't get a word you just said, Dylan.
Yes, I did.
Don't watch it. Here.
Okay.
What's the least common denominator in the denominator?
In the denominator would be,
Put that up there like that
yeah.
so you can see what we're doing. What's the least common denominator between that denominator and that denominator?
Um, you would do 2x plus 18.
No?
Wow. Uh,
Notice that this is just twice this.
oh, that is, yeah.
So
So
my
just x
common
plus 3.
denominator is this.
Yeah,
In other
just,
words, remember what the rules are for least common denominator. Both
uh,
terms have to divide into it equally. Well, this one
okay,
divides into it exactly one time, and this
uh-huh,
divides into it exactly two times. So this
okay,
satisfies the requirement that we have for least common denominator.
yeah,
Okay, I'm going to put it over here also. What
okay.
goes here?
And then it would be, so 4.
Goes there. That's the same thing. In other words, I didn't change anything.
4. No.
In
And
other
then 1.
words, what goes here over here?
1.
Is that the same? Is this thing the same as this thing?
Simplified, but no.
No, so it can't be 1.
Uh,
What number could I put there that would make it the same?
that'd make it the same. We would do, let's see,
Yes, say it.
2.
2.
Mm-hmm.
Now is that the same?
Yeah, yep,
Yeah, because if I divide top and bottom by 2 here, I get 1 over x plus 3, which
yeah.
is what I started.
Okay,
Okay.
cool.
Now I can just add the numerators. So
Uh-huh,
it becomes 6 over that. So that's what I end up with in the denominator, right?
uh-huh,
Now flip and multiply. So it's 2 over 4x plus 12. I'm going to
uh-huh.
multiply by 2x plus 6 over 6.
Same switch flip. Okay,
Okay, so all I did was I flipped it and multiplied it by that.
okay.
Now, notice that I can take that 2 and turn it into a 3 by dividing top and bottom by 2.
Uh-huh,
And then notice that this is exactly twice that.
uh-huh.
Okay, so I can cross that. In other words, I can factor a 2 out of that so that it's 2 times 2x plus 6. And then cross out the 2x plus 6, and I'm left with this 2. So now what do I have? The only thing I have left in the numerator is 1, because everything's been crossed out. And in the denominator, I have 2 times 3, 6.
Which is 6.
Here's my
And
answer.
that's your answer.
Mm-hmm.
Okay, okay.
So this was actually far easier than the last problem. For one thing,
Yeah,
finding the least common denominator was pretty easy because one
it
is
was.
a multiple of 2 of the other.
Uh,
And I didn't have to do anything to the numerator.
okay. Yeah,
So it doesn't really get any harder than number 11.
yeah.
You have 4 different subfractions.
Uh-huh,
In the I suppose it could get harder if you added a third one in the numerator and a third one in the denominator, but
for
and
sure.
they might do that to you.
Uh-huh,
All right, Dylan, I will
okay,
let you go, and
okay.
good luck on your test tomorrow.
Yeah, thank you.
And
Appreciate it.
I will talk to you next time. I'm not sure when your next scheduled is, but I'm sure my calendar will show me.
Okay, yeah.
Do you have
Could
any
we
plans
do,
for the holidays, or let me bring it up here.
I don't think we have any for winter break.
Well, we don't
Uh,
have, let's see if we have you scheduled for anything here.
yeah. Could we do Sunday by chance?
Yes, we definitely can. I actually have you scheduled for next Monday and Tuesday night. You want me to cancel those?
Uh, oh, let me think here. Our test is on Tuesday, so we can cancel the Tuesday night.
Okay, let's cancel the Tuesday and replace that with a Sunday.
Yeah, perfect.
Okay, what time's Sunday? This is what my Sunday looks like.
Okay, we could do, could we do 5?
Yeah, definitely. I got
Okay,
5 in there. Let me type you in.
cool. Perfect.
And that's at 5 o'clock. I'll talk to you
Oh,
Sunday at 5.
sounds good. Thanks, Mr. Cowan.
No, have a good rest of your day. Bye-bye.
All right, you too. Bye-bye. Get some rest.